Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group and we do online and in-person presentations. Last week we did an in-person presentation at Brisbane Business Hub in the Queen Street Mall in Brisbane, and that was our biggest turnout ever for our one that we've run ourselves. We've had bigger ones where we've done them in collaboration with the Brisbane Business Hub themselves. Thanks everyone for coming along. What I'm going to present tonight is going to be a repeat of my session there, which was an introduction to pandas. So this is more a beginner level one, and it's going to be running in Google Colab, so you don't even need to have Python installed on your computer or pandas installed on your computer. You can just run it all on Google's Colab servers, and they just need you just need a Google account to be able to do that. So if you've got the meetup details, or even in the below the video, there'll be a link to the Colab notebook that I've prepared. So if you click on that link, you'll be able to start a Colab notebook and follow along as I do it. I do the exercises tonight. Now the first thing you'll want to do is copy this to your own drive. So you click on this big button here, copy to drive, and that will give you a copy of it, so you can do whatever you like to it. You obviously don't have permission to make changes to my one anyway, so I'll just hide that. So and if you really stuff things up, you can go back to the original and make another copy. Now this copy here, I'm going to share it with you because I might end up adding some things to it. I don't think I added a lot tonight, but just in case I do, anyone with the link can be a viewer. Copy the link, and I'll paste this in Slack in the Learning to Code section, and I'll also paste it on YouTube chat, so you can ask questions in either of these venues. YouTube chat tends to censor a lot more than Slack, so I'm not even sure if that'll make it through, but you saw that I pasted it there, so if you can get it from there, that's great. But here it is on Slack, so Learning to Code. If you need to get access to our Slack channel, then you can send an email to skypyproject@gmail.com, and send them your email details and they'll connect you in. Alright, I won't bother posting that on Slack because anyone on Slack has already got access. Okay, so this is Google Colab. So it's just a web page, but you can do stuff with it. It's made up of a bunch of cells. You can see each cell has got a rectangle around it, and the cells can be either text, formatted text, or they can be Python code and actually run things. So these are Python code, and this one's a text. And in between each one, you see if I hover in between two cells, I get an option of creating new code or new text. So first thing I'm going to do is going to connect in, and that means that Google's going to give me a server with a certain amount of RAM and some drive space, and that I can use that tonight. So that's just initializing that. So the first thing I'm going to do in one of these Python code cells is actually not run Python code. I'm going to run a command line code, and so I'm going to start it with an exclamation mark. Now if you've got any questions, remember to ask. Like if I'm skipping over this, but I've been through this a few times on other nights, but if this is the first time you're here, then feel free to ask questions about it. So exclamation mark means run a command line code, and I'm going to use the Python pip command to list all the third-party packages that have been installed, and then I'm going to filter them, that's what that pipe symbol does, to anything that includes a particular pattern of letters, and I'm going to look for the letters pandas. And so these are all the third-party libraries that have got the word pandas in them, and the one that we're interested in is pandas. So pandas installed on Google Colab is 1.5.3. The latest pandas is about 2.0.3, but everything we do tonight will work on 1.5.3 as well. Okay, now if you're writing a Python program or in one of these Google Colab cells, you need to import any third-party libraries that you want to use. And so I could just say import pandas, or I can import pandas with an alias, and this, what most people do is they import it with an alias of PD. So if you do the same, then your code's going to look the same as everyone else, and everyone will understand that PD means pandas, and that means that later on we can, whenever you want to use pandas, you just use PD. So we'll run that cell as well, and Google Colab remembers from cell to cell what you've run before it, so that like it even puts a number there. You see it says which was cell 1 and cell 2. I can't point to them because the number disappears. And now we're in the third cell, which doesn't actually have a number because it hasn't been run yet. So the first thing we're going to do is grab some data. So I thought we'd go along to Brisbane City Council. Let's see, control click. Yep, Brisbane City Council, and they got an open data set that we can use. So they've got a download a CSV file of all the public art collections that are around Brisbane. So they've given us a URL. Let's have a look back here. They would have given instructions on how to get this data. Oh, I just copied the URL, that's what I did. So I've just hovered over there and copied that link address and put it into my cell here. So it's based on March this year, and it's a CSV file of all the data of the public art. Now I'm going to use the pandas command, pd.readcsv, and I can just put in the URL, and pandas will go off to the web, download the CSV file with that URL, and put it into a data frame. And normally that's enough for you to do, but I found that with this one, the default encoding of Unicode, UTF-8, didn't work. So I've used an encoding of CP1252, and we'll look at later some different encodings, but that's why I've had to put in an encoding here, and that'll read that data straight into a data frame, and then I can look at the data and display it. These lines here, starting with the hash sign, are comments, so they're all in green, so it's only 3 lines of code here. So let's run this cell, and you should get the same thing coming up. So on your computer it will have gone off, well actually on the remote server you're using will have gone off to the Brisbane City Council, grab that data and put it all into a data frame. Now Google Colab is quite well integrated with pandas, so it knows how to display these data frames in quite a pretty manner. So it's set them up as a table with each row, with a being able to highlight as I hover over them, and they're alternating on grey and white even when I'm not hovering over them. It shows the first few rows and then ... and then the last few rows. So it's showing there's 193 rows total, and it's showing the first 5 and the last 5, and ... to show there's some in the middle. Similarly, there's 8 columns. It managed to fit all 8 columns onto the page, so it hasn't had to abbreviate there. And this is the information that we've got, like number 4 here is Robert Burns Memorial by Samuel Willis in Centenary Place, Fortitude Valley, and it's made out of bronze, and that's the description of it. It was installed in 1929, and the latitude is 27.46 degrees south, and the longitude is 153.03 degrees east. Okay, so let's have a look at some of the things we can do with these data frames. Now, one thing, selecting data with the data frames, we often use these square brackets, and then we can select different things. So we're going to select a column now. So we just put the column title, and you see item title there. That's come straight from here. So it's case sensitive. and it's got an underscore in the middle, and it's capital I at the beginning, and the rest is all lowercase. So if I say dfart, so dfart is my data frame of art data, and if I use those square brackets and I'll store the result in a variable called s, then let's have a look at what s is, and I'm just using a print statement here to tell me what the type of dfart is and tell me what the type of s is. So if I run this, the print statement says dfart is a data frame and s is a series. So both of those data types have come from pandas, and basically a data frame is a series is a one-dimensional array of objects, and the data frame is two-dimensional, and basically it's just made up of all these columns, and each of those columns is a series. So if I just say S here, it will display what's in the series. Okay, now I've got Gupta 51 has said I get this error, but I actually can't see the error that you've got. So you'll just have to give me a more descriptive description about what you're seeing, and we'll see if we can solve it for you and put it up, and if someone else can answer it, feel free to throw an answer up in the chat. But the cells, like I haven't made any changes to these cells, I'm just running them, but you do have to run all of them, so you have to make sure you run all of them right from the start. This one's not necessary to run, but this one is, import pandas as PD. That's about the only thing I can think of you've done wrong, is you just haven't run that cell. And you run them by clicking on the play button, or you can see you can use Control Enter to run. So if I do Control Enter in a cell, it runs it and it leaves you selected in that cell, or if I do Shift Enter in that cell, it'll run that cell and then hop down to the next one. So Shift Enter is quite a fast way of running a few cells. So you can see I'm just running the cell and jumping down to the next one, and you can see the output below each cell. Okay, so to get a sub data frame, you saw how we get one column, but if we put several columns and we put these in as a list, it actually gives us a data frame, because it realizes that that's two-dimensional, and it's what's different is that's not a string that's been provided there inside the square brackets, it's a list. So these square brackets here are the pandas data frame selectors to say I want to select something out of my data frame, but this here is just a standard Python list that is a list of the column names that we want to have. So by doing dfart and then this list of names, we've now got a sub data frame which is 193 rows and 3 columns. We haven't done anything with it. All we've done with it is displayed it. It's good to see Gupta's fixed his problem. That's good. So we haven't done, all we've done was displayed it, and then it's been lost. We haven't stored it anywhere. Alright, so let's have a look at what we can do in Google Colab with this data frame that we've got. And it's just a sub data frame with titles and latitudes and longitudes. So there's this wizard here. If I click on this, it'll convert the data frame to an interactive table. So that might be interesting. And here we go. It's got pagination. I can choose number of rows to show per page, and I can jump to any page, and so I can see all the data that was in those missing rows in the middle. And there's even a chart icon here if I want to chart some of this data. So maybe I want to show latitudes and longitudes. So they said, which one of these would you like? And we'll go, actually we want latitude and longitude, and that should give us a bit of an idea of how the where they're geographically located around Brisbane, these artworks. So let's it's worked out all the Python code for us, very clever. We click on add cell, and we can see that it's used a special Google Colab third-party library that allows us to get this data frame, even though we didn't store it anywhere. Google Colab has stored it, and so it's going to put it into this variable here, and it's used a nice long name that is unlikely to clash with one of our names. Then it's got a little bit of a function here. It's defined a function. You see our Python indents code to work out the different code blocks. Everything that's indented 2 or more spaces here is part of this function, and then within the function anything that's indented 4 spaces is part of this for loop. And so what it's doing is just going through all the column name pairs and plotting them. Now the column name pairs that we've got, it's got index latitude and longitude. Alright, now we actually want, if we run this, so yeah, we'll run it by hitting the play button. We don't want index and latitude. And remember, index wasn't actually part of our data frame, but they've taken the index and gave it copied it into a column, but we don't need to worry about that. So let's plot latitude and longitude, and we can see it's plotting it the wrong way around. This should be east and west, and this should be north and south. So we want to swap these around. Okay. And then it's going to call this function here, and you can see that there's actually another thing we could change here, scatter plot size. So we can put that in as a named argument, scatter plot size. Yep, and I'll use the hint because it'll spell it properly for me. We'll do 7.5. And we'll run this. So this is actually the challenge that I've set down here for you to do, so I'd recommend you having a go at this, and this is really recommend having a go at these things, because that is how you learn. Alright, so we've made it bigger. It's probably a bit too big, so let's just change it down to 5. We've made it bigger. The latitudes now run on the vertical axis, so that's our north-south position, and our east-west position are the longitudes. So and they're running across the page. So you can see, in the CBD, that's where most of the artwork is, but there's some out here and out in the suburbs. Okay, so that was the challenge. Modify the code to show just the latitude versus the longitude with scatterplot size equals 5. Yeah, there I said 5 is better. Alright. Now I've done it again with the same code. So remember the first one, it uses Google Colab third-party library. I figured we didn't really need to do that because we actually know the data frame we want to use, and we're not needing index, which is in their one. So we can just write scatter plots without using that library. I thought I'd add a few things to it. So for example, I thought I'd add some the titles, so I could have the titles on the map to show which was where. I did that first with showing every title, and it just was a real mess. So I said, okay, well, I'll just do every 5th title. So I just checked the index as I was looping through, and if it was divisible by 5, which meant the remainder after modulo of 5 was 0, then I'd include it, otherwise I'd ignore it. And so I referred to each part of the data frame using this at locator. And so that at is really good if you're trying to find a single element in your data frame, and you just give the row and column, and you give them by row values. So the index IDX is my variable, which is part of the data frame index. In this case, it just goes up from 1 to however many there were, and the column name is what's come through, being passed to this function, which of course is going to be longitude for the x column name and latitude for the y column name. And I'm only showing it if it's not really close to the center, because there's just so many points in the center, they just all get clobbered. So let's run this and see what it looks like. And here we can see a few names that have popped up around, but nothing in the center. So that's an example of something you can do yourself. So just try these different things, see if they work. You'll notice, okay, that worked. I put a semicolon here to hide any text that might come out, but none came out anyway, so you didn't actually need the semicolon there. Okay, so we've just seen how to use @ to access a single data element. Now we can access multiple elements using LOC. So LOC works just the same way as @, providing rows and columns for the multiple elements that we want. And there's also IAT and ILOC equivalents that, rather than using the index names and the column names, it uses the index counts and the column count. So that'll be, the third row down, or row 3 down, starting from 0, and row 5 across. We could refer to those indexes. I'm not going to look at the IAT and ILOC tonight. I'm just going to look at @ and loc, and also the selectors, where we use the square brackets to, as we saw before, just pull out a few column names. So let's check index row 4 and column item title, and that's Robin Burr's Memorial, which, remember, I was looking at before. So that's using loc the same way as @. Well, let's do @. Yeah, so loc actually works for single elements as well, but they recommend, if you're just doing a single element, just to use @. It's probably a little bit faster. So with loc we can do a slice of rows, so 2 to 5, and it works a bit differently to how Python works. Python, if you did a slice from 2 to 5, it would be 2 up to, but not including 5. But pandas, you go up to and including 5, so 2, 3, 4, and 5 are included. So that's quite confusing and unusual and unexpected for a lot of people coming into pandas, but you get used to it after a while. Okay, so if we're just providing rows, we don't need to specify the columns. If we're just providing columns, a slice of columns, then we do need to say, and we want every row if we're going to use the .loc selector. So here we go, we've got columns from artist all the way up to material, and we've got every single row. So just a colon means everything of all the 193 rows. You'll notice here I had to put a space on the end, and that's because the original data, the column names had spaces on the end of some of them, just to be confusing. So it wasn't working when I was just using material without a space, and then I worked out that there was actually a space there. So to find out why it wasn't working, I said, well, tell me what all the column names are, and it said, oh, these are the columns, and so you can see all the strings there, and then suddenly I saw the location had a space on the end, and material had a space, and description had a space, and installed had a space. So yeah, well, where did these we'll look later where the spaces came from, but we can actually fix the spaces if we want. Okay, so we've got a question here. Can matplotlib do 3D plots? Yes, it can, but I'm not going to really go into Matplotlib tonight. So there's a huge range of plots that Matplotlib can do. And another one that I use as well is Plotly. So either of them, they're both quite powerful, and they sort of have strengths in different areas depending on where you're trying to use them. Matplotlib is the older one of the two. It's probably got a bigger range of plots, but Plotly is more modern, so it can actually look a bit prettier in places, and is more linked to JavaScript and web pages. So you can it drives it by linking the Python to the JavaScript and automatically creating JavaScript to make an interactive plot. So that's why I like Plotly, because it works very well in web applications. Alright, so if we want to rename it, what we have to do is we have to create a dictionary which has got any name that we want changed, and then for the key, and then the value in the dictionary that it maps to is what the new name is going to be. So I'm just going to create a dictionary using dictionary comprehension. So in just one line I can find all the names that exist and use them as the keys, and then do a colon to say the next thing is going to be the value, and the value is going to be the same thing but with any leading or trailing spaces or white space stripped off it, which is just a built-in string function. So you can see just this one line here has created this list, this dictionary, and for example, material with a space is mapped to material without a space. So if I put that into dfart.rename and say the columns I want are now new names, it renames them to those new names. And what I've done is used in place equals true, and most of the functions that you call on data frames, so these methods that you call on them, they have an option either in place false or in place true. And if you say in place equals false, it creates a brand new data frame without affecting the existing one. And if you say in place equals true, then it edits the existing one. So you have to decide which is going to be more useful for you. Normally if you go in place equals false, that's quite good for keeping, if you're writing functions that you don't want to modify any data that someone's passed into the function, then you would use in place equals false. But in this case, where it's just a small change and we're just fixing the data, there's no need for the old data once we've fixed it, so we'll just do it in place, and then everything that's linked to that will start using that new those new column names. And there we go, we can see what the column names are, and they don't have the spaces in them. Alright, so let's have a look at what caused the problem. Why are there spaces in those column names? So I've just written a little bit of code here that is going to open up that URL that we originally provided and save it in a file, and then we'll open the file and we'll write the data into it, and then we'll have a look at just the first few lines of that file and see what they look like. And I've used, rather than Python code, I've decided to just use I could put it done in 3 lines of Python code or 1 line in the command line, so I've just used the command line head, and we can see the first line there's a few spaces between the commas and the text, and that's what's caused our problem. Okay, now by creating this file, it's created a file in Google Colab. So if we look over here, see this folder and files, and you click on that, you'll see that we've now created a file called publicart.csv. Now that file is you're going to lose that at the end of your session, so don't save anything here that you want to keep you can link it to you can mount your Google Drive, and of course stuff that gets saved to Google Drive will be kept, so you could save stuff in there if you want. But anyway, this one doesn't matter because we just got it from the net anyway, and we're just going to be using it here. So we're going to open up this file. So I'm going to we're going to read it rather than write it, and just B to say it's bytes that we're reading, not strings or text, and then we have to convert it into text. And remember, the problem that we had right at the beginning was that when we tried to load it into a data frame as Unicode UTF-8, it gave us an error. So what I'm going to do is I'm going to try to decode each line into Unicode 8, but I'm going to have a try and accept around it, and if there's a decode error while it's doing that, then it'll jump down to the decode section and it'll start to try different encodings and see if something else will work, and then we can choose which encoding we want. Now I've gone to this link here and it lists all the standard encodings, so let's have a quick look. So these are all the encodings that you can have. So I've chosen CP1252, which is a Windows one. I've chosen ISO 885, well, I've chosen Latin 1, which is ISO 8859-1, which is another common one, and I've chosen Mac Roman. And they've all got aliases. You can use underscores or dashes, either will work. So let's have a look. Yeah, so these are the three I've chosen: CP1252, Latin 1, and Mac Roman. Okay, so if I run this, any line that decodes without a problem, it'll just won't do anything with it. But any line that has a problem, it'll print it out with the three different encodings. So let's have a look at some of these here. So line 183 was a problem. So the first, it shows us a byte string. In Python, byte strings are represented with a B out the front and then quotes around it. And I've even included the whole string includes a carriage return, a new line at the end. Then I've converted it using CP1252, and that's what it looks like as a string installed through the World Expo 88 site. And we can see here what the problem is. Most likely is this fancy quote they've used rather than just an apostrophe, and the fancy quote is not part of the straight ASCII set, but they haven't encoded it as Unicode. They've used a different code to the Unicode code for that quote. So and looking at CP1252, that looks alright. If we look at Latin 1, Latin 1 doesn't even understand the code that was used, which was, you can see the code here, X9188. And Mac Roman thought that it was E with an umlaut, is what that code was. So that's how I chose CP1252, just by looking at the data and going, oh yeah, well, it looks like they've actually encoded it in that one, and that's what. And most of the lines here that are a problem are ones to do with those fancy quotes. So there's another one that is a fancy space. So I don't know, it could be a non-breaking space. I don't know what that code is, but Mac Roman decided that was a T superscript. Here we go. Here are some more fancy quotes. X91 for the left one and X92 for the right one, around Balimba, and yeah, CP1252 is the one that worked. Alright, let's go back to our data frame. I'll just show it again so that we can remember what it looks like. Now we can use a list of Booleans on rows or columns to specify which ones to include, and we can use the .lock to do that. So Here we go. We've got two things. So remember, rows and columns. So anything left of the comma is rows. Anything right of the comma is columns. Rows, we've said everything by just a colon means slice, but everything. And for columns, we've gone true, false, false, false. So I'll just put trues only there, and there are the only trues, and the rest are all false. So if I run that, it shows me just this first column and the third column. So remember, item title is the first column and the location is the third column. So by putting this list of booleans here for my columns, it's telling my data frame to just include those ones. Now that seems like a fairly cumbersome way of selecting columns, but there's a reason that they do it, and it's because they've also got a way of easily generating these lists of booleans, and that is by creating these expressions. You can do an expression like this. So I say, look at my column names. I want to run the string function contains an underscore. So if I run that, it looks at all the column names and it tells me which column names have an underscore in the name by giving me this list of booleans, and it's the first one and the third one and all the rest are false. So I can then put that together and say, alright, well, show me that data frame just with the columns that their column names contain underscores, and there we go, we get the same thing. And that makes a lot more sense than looking at lists of booleans. So you could also do that on, so remember this here is a list of booleans. I can pass that through just on the square brackets to columns, and columns was a is an index, which is another data frame, another pandas data type, and it'll just produce the column names that we want, and then remember when we pass a list of column names through to our data frame inside the square brackets, it'll just show those names. So there we go, the same thing. It's probably not showing you a lot, but if we add another code cell and say, well, what does this look like? That produces an index, which is one of these array type data types of from pandas with just those two strings in it, and you've already seen what that looks like. That's a list of booleans, and if you want to just remember what dfart.columns looks like, it's this index with all the column names. So our way of filtering out column names by a list of booleans works on this data type as well. These sort of filters are more common on rows. I just it was hard with so many rows in this particular data frame for me to come up with an example, but here's one. I can if I run this expression here, dfart installed equals 2022, that will give me a list of booleans, and then it will, which will only have 4 trues in it, and then that sending that list of booleans off to log, it only returns those 4 rows. Now it turns out in this case we can actually go even shorter, just a little bit shorter. So I don't even need the dot lock. I can just say dfart, and if I'm providing a list of booleans in between my selectors, it'll just give the rows with the trues for those ones, and if I'm providing a list of strings for column names, it'll just provide the columns for that. So it's a little bit confusing because you go, well, what's it doing? Is it providing columns, or is it filtering on columns or filtering on rows? But it looks at the data type and decides which one to do based on which data type is being provided to it. And that Oh, that's how it works. Okay, so let's have a look at some more data. I'm going to look at some traffic data now, and the reason I want some traffic data is I want some more numbers so that we can start doing some mathematics on the numbers, and there wasn't a lot of numbers in our art data frame. So let's go off to our traffic management key corridor monthly performance report, and we'll grab the CSV. The suggested URL is this one, and you'll notice at the end they say they want a byte order mark equals true. Now when it comes to Unicode UTF-8, if you're using UTF-8, byte order mark doesn't matter because they're all single bytes. So in this case we actually don't want the byte order mark, so we'll just leave that off. And so the byte order mark is telling you when you've got say 2 bytes making up 16-bit. So a byte is 8 bits, and each bit is 0 or 1. So if you're using 8-bit values, they're a single byte, and so there is no byte order, it's just a single byte. When you're looking at so that'll give you a number up to 2 to the 8th, which is 256. When you go above that, then you need to go say 2 bytes, and you're going to have a high order byte and a low order byte, and it's just saying which one comes first, and that's what the byte order mark tells you. And it's called big endian or little endian. And different CPUs have either big endian or little endian. So that's when you'd use a byte order mark, but UTF-8 is only ever single bytes, and so there is no need for a byte order mark. All right, we're just saving this as binary, so we're not going to be doing any encoding at this stage. So let's just have a look. There's the first few lines of our file that we've created, and now if we look over here on the left, we've got a new one, traffic.csv. So we've downloaded from the web and we've saved it locally, locally being on the Google Colab server. Now we want to read that CSV file from the file, and so I'm showing a different form of pd.read CSV now. I'm going to read it, and I can just put in a file name rather than a URL for a network location. I'll just put in a file name, and that will work it out as well and store it in our data frame, and I'll just create a new one called df traffic. Okay, so there's all our columns and lots of numbers that we can do things with. So when we're doing arithmetic, you can do arithmetic on a whole column at a time, and it's really you should hardly ever iterate through a data frame one row at a time, or a series one value at a time. You should try to find the operation that will do what you're trying to do in a single line rather than iterating, and you'll get much better improvements. Alright, we've got a question here. Can I have Boolean logic and an OR for our filters? And we do, and I will get onto that soon on how to do that. Alright, so the way it works is that pandas has overridden the Python operator, so in this case it's the slash for divided by, and said rather than just dividing two scalar numbers like two floats or two integers, it's taking this, which is a whole series of numbers, 972 numbers, and dividing each one by 24, creating a new series, and then with that new series I'm going to add it into the existing data frame as an extra column on the end. And columns, data frames are actually based on columns, which took me a while to get used to. I'm used to databases, which are based on rows, but data frames are based on columns. So you can easily add a column to a data frame. In databases it's not so easy to add a field, but databases you can add rows very easily. In data frames You can sort of add rows, but it's not a common thing, not so common. Alright, let's have a look at what happens when I run this. I create a new column at the end called volume per hour average, and these numbers here are just the same as these average weekday traffic per day divided by 24. So this is giving me what the average per hour is, this is what the average per day is. And it's just done it in one line. It's done all 972 rows of my data frame. And they don't have to be just a single calculation like that. You can do a calculation here where I take this column, multiply by that column, and then I add that to these columns, multiply by each other, and then divide the whole thing by this column added to that column. And what I'm trying to do here, so what I'm doing is I've got a formula here for the volume and transit time in the morning and the volume and transit time in the evening peak, and I just want to have a average transit time in all peaks of the day. So I've just taken those column names and put them into variables just to make it a bit shorter so that this formula wasn't too long, and then I run that. And it's added another column to the end, 758.249, okay, which is those 4 numbers all done in this formula, and it's done that for every one of the 972 rows. So it's very, very powerful. Now, when I wrote this, May was the first month being shown here, and now it's June. So we can filter, and so remember how we filter. We'll put in an expression here, show me all the rows where the month equals May, and there we go. So now our second row is got these values here, and I really just did that so I can check the calculation. So what I'm trying to do, 1865 times 1182 plus 1899 times 1023 divided by 1865 plus 1189, and that should give me 1101.78 when I just use normal Python scalar maths. So when I look up here, 1101.78, so it's come up with the right answer. Now, we had a question before, how would I do more ands and ors? So I can we don't use the words and or like you do in Python, because they're keywords and pandas couldn't do anything about them. But what we're going to use is the bitwise, what are normally the bitwise operators, which is ampersand for and, or you could use the pipe symbol for or. And we're going to say I want the site ID to equal 2. So this has given me site ID 2 in the month of May, and you can see it's for every year, 2023, 2022, 2021, 2020 and 2019 for the last 5 years. So that's how you do ands and ors. You do have to put parentheses around each of those expressions, because otherwise in operator precedence the ampersand would normally have a higher precedence, and it'll try doing the string of May ampersand DFTFC rather than May equaling this and site ID equaling 2. Okay, can we do group-wise? Yes, you can. So, like you can let's say we wanted to do I don't know, just try, we'll create a column called May 2. Let's see if this works. Yeah, we'll just give it a string. Value instead. Oh yeah, so value is trying to be set on a copy of a slice from a data frame, and that is true. Yeah, so what I should do here, I should create the other column first, and I'll just call it no and run that. Okay, and then I use dot lock, and I want they're the rows that I want, and the column is going to be May 2. And then I can look at the what's now in DFTFC, and it'll have an extra column in the end, May 2. There'll all be no's for the ones we're looking at, and if we have the one that we had before, which was this filter here, and they're all the ones that are yes, and let's just add a couple more. So what do I do is in yep, need to put so I'm looking at all site IDs 2 and 3 for all the years, and you can see all the 2s are set to yes and all the others are set to no. I hope that made sense. It can be quite confusing, some of this stuff. Alright, check using a certain filters. So here we go. I'm using the ampersand a few times. So I'm wanting the year 2023. I want the month to be May, site ID to be 2, and I want the average seconds. So I'll look at that, the series, which is that column, but it's been filtered, so there's only one value in it, and I want to look at that value and assert that it's equal to average TT that we calculated before, and if it is, nothing will happen, so nothing happened, so that's good. And then I can say, well, tell me what is in there, and we can see what that that series is just an index 19 and the value 1101.78. I guess it is poor in database kind grouping. Okay, so there's a function that I don't use very often called query. So you say dftfc.query, and then you can write a statement that looks very much like a database type query. I wonder if I did any down here. No, there's none. I haven't done any examples here. But yeah, look up query on database. So if you want to, I've got a link here to pandas. And in the documentation, we can look at the user guide, and in there you could look up data frame query. So you can do something like this: data frame query, and you have a string, and you say I want column B to equal the same as what's in column CC, and it just returns all the rows that satisfy that expression. Okay, so getting close to the end. All right, so question: if I wanted to do the sign of, so the mathematical sign of every value in the column ID, can I just use the math.sign function like I did for just the normal Python operators? And of course that won't work because it can't convert the series to a float. So I don't like having cells with errors in them, so I'll just get rid of that cause of the error. But there's another third-party library called NumPy that Pandas is really closely built on, and it's got functions that work on arrays or series, and so to use it you'd use np.sign rather than math.sign, and then that will work. So we can see sign ID in this last column at the end. We've added it to the end, and it's just calling the sign of every number that's in this ID column. Okay, I want to convert, this is a common thing to do. I've got a year and a month column here, and I want them actually all to be dates, date time, so that I can use them a bit more easily. So I can use the pandas to date time function, and I have to convert it into a format that's going to work. So I take the year as a string, so I can convert it from an integer to a string, and I add in the string of the month, which is a 3-character string, and I use the Python format %y%b, which is 4-digit year and 3-letter month, to convert all those to dates. So just that one line there gives me a column at the end, year, month, and you can see they're all dates now. So that's 1st of June 2023, 1st of June, all the way down to 1st of January 2019. So now I've got that, I can I want to make the site names a bit more interesting. So currently the site IDs are just 1, 2, 3, 4, 14. They just look at numbers and a bit hard to identify where they've come from. So we'll just change them to site name, which is site 01, site 02, site 03. So that's just a bit clearer where those numbers have come from. And I'll just take a subset of these columns. And now with that data, I can pivot the data. So if you've done Excel pivoting, you'll be familiar with this. And so what it's doing is it's taking, so this is more like your database layout, and this is more like your spreadsheet layout. So you can see now the column names have become site 1, site 2, site 3, while before they were values in a particular column. And then the values inside it have all come from this column, average weekly daily traffic vehicles per day. We can now fit quite a lot more data onto the page, so it's actually showing all the data that we've got for that column, while previously I had to limit it just to the first 30, just so it didn't create too long a list. So pivoting is quite useful, and really changes the data frame. You can do transposes, you can do melts. So melt is an unpivot, so you can go from the pivot view to the other view, which is more like a database view, if that's what your data requires. Okay, so that's it for my intro to Pandas. I hope you've enjoyed it. Next week is the first week of the month, so we do absolute beginner sessions online, so I'll be looking at lists and dictionaries, I think. And then in another few weeks' time, in August the 23rd is our next in-person session, and the 2 online sessions between those in the middle there will be machine learning. So I hope you've enjoyed it. Click like if you have, and visualization, yeah, that's a really good topic, and yeah, I'll add that into my list of topics. We can do that one day. I could fill a whole session on visualization. So yes. Okay, thank you very much.